Right, question 2 of this exemplar question paper, grade 12, sikhuluma second law, Newton's second law of motion, right? So in the description below, uzothola ama-links for amanye ama-questions akhona kule question paper, but in this video sophendula question 2 pen, right? This is an exemplar question paper yango 2014, a physical sciences paper 1, right? The question ethi ifundeka ngale ndlela le ithi a light inelastic, sometimes sebenzisa word ethi inextensible. A light inelastic string connects two objects of mass 6 kilograms and 3 kilograms respectively. They are pulled up an inclined plane that makes an angle of 30 degrees with the horizontal with a force of magnitude F. It's a force of magnitude F. The value of that force is not given, it's just a force. I think somewhere we calculate. Ignore the mass of the string. So it's not two yama body, it's a two body system moving up an incline of 30 degrees. Statements at City. The coefficient of kinetic friction for the 3 kg block and the 6 kg block is 0.1 and 0.2 respectively. So the 0.1 is for the 3, the 0.2 is for the 6 kg object. I'm a coefficient of kinetic friction. So 2.1 I'm skipping in this video, but in the description below ngizomstate Newton's second law. Tina focus only on our calculations, and answering our questions are relevant, right? Because well, ama laws ga Newton, it's not something komele cram angisho, like komele wafunde wa understand, ne? Wafunde wa understand. So the questioning we skip, but in the description below I will also state this second law. 2.2. How will the coefficient of kinetic friction be affected if the angle between the incline and the horizontal increases? So this angle got 30 degrees. What's going to happen to our coefficient of kinetic friction if this surface were to be raised, or the angle between this horizontal and the incline were to be increased? But instead of having 30, let's say maybe 50 degrees. The question is, what's going to happen to our coefficient of kinetic friction? Write down only increases, decreases, or remains the same. The answer in this question got 2.2. It remains the same. Why it remains the same? Okay, I think provide a reason. They're only expecting us to do what? To write down only increase, decrease, or remain the same. But for the sake of this video, so provide a reason. It remains the same because coefficient of kinetic friction changes it changes because the coefficient of kinetic friction I think it depends on nature of surface. Why do increase I force? Whether we change why do increase I look I force? Whether we increase the angle of the incline? Whether we seven side different steering? Where do we are push? We are pull. The fact remains is that a coefficient of kinetic friction, it depends only on the nature of the surface. So if lama objects lawa siwasusile mhlambe siyawabeka on a different surface, then that's the only time ama coefficient of kinetic frictions wethu anga-change khona. It's either so increase or a decrease, but for this case azo remain the same. Why? Ama coefficient of kinetic friction depend only on the nature of any surface. So 2.3, and this question by Tango. Now 2.3, draw a label free body diagram indicating all the forces acting on the 6 kg object as it moves up the incline. How many marks? 4 marks. So free body diagram yakho komele ibe na 4 yama forces. So this is our blob or our dot. This is the incline. This is the incline. It's not necessary ukuthi uyibhale the incline lena, but for me I draw because sometimes inokunceda, especially nangabe ufuna ukudraw le vector ye normal force le, yabona. Ngoba sometimes abanye banokuthi nabayibhala le vector le I normal force yabo uyithola sometimes is straight, sometimes iba 2 squared. So bheka now my force is weight. It's the normal force, the weight, because it's going up an incline for the 6 kg block. Up an incline on a tension, and then that is one. Is the surface rough, all right. Okay, so since it's a coefficient of kinetic friction, it's not 1, but it's less than 1, so it means lana sizoba ne friction. Once you have a coefficient of kinetic friction a greater be less than 1, it means that sinani sine friction. So the third component lana kuzoba frictional force. So now my vectors were to on the 6 kg block or object. The 6 kg block, free body diagram yakhona is over now 1, 2, 3, 4 forces acting on it, right? So study 4 marks yakho a collector. Kwamele wenze sure ukuthi ama free body diagrams yawa practice ngoba that's where you score ama marks ku Newton's laws, right? With 2.4, but they calculate the tension in the string if the system accelerates up the inclined plane at 4 meters per second squared. 2.4, 2.4.1, 2.4.1. All right, again. F net is equal to MA. Is going to be F net is over equal to MA. Over this is second law. But CP acceleration of 4 meters per second. So it means the system is accelerating. So this is going to be the second law. And the 6 kg block is moving up the incline. It's moving up the incline. It's for the tension in the string. Ne? Friction I can calculate. I'm showing you the coefficient of kinetic friction. So F net weight is some calculator along the inclined plane. Over that's where the object is moving. Right? All right again. I think pin and draw iloganje. If free body diagram for the 6 kg block. Nylana. And then over weight. Let me use a different pen. Ukhumbule the weight inani inama components. You know FG perpendicular. FG perpendicular is equal to FG cos 30 degrees. Lana there's an angle of 30 degrees, and then sibanani. So we are sibano FG parallel equal to FG times sine 30 degrees, right? 30 degrees. Lana sakumula no F lana sino tension, sino normal force, ne? Sine normal force. Now, so kuna 1, 2, 3 forces acting in the inclined plane. These forces lawa yours was not ukuthi sithole F net, right? Then the left hand side I also include the forces side the ne? All right, I think another pen red. Now let's choose up as positive. Up the incline is positive, so it's going to be plus T minus F G parallel, and then it's equal to MA mass times the acceleration, ne? So it's accelerating up an incline, so even the acceleration rate is over positive. But the system is accelerates up the inclined plane at this value, so it's going to be positive 4 by accelerator phezulu. Why do I need a direction for acceleration? Acceleration is vector quantity. Now if we calculate a tension, which I don't have, frictional force I calculate, né? The frictional force is always equal to mu k times normal force. So the normal force is over equal to Fg perpendicular, the perpendicular component of the weight, ne? It's not that okay, try to do n over equal to bani the weight, but on an inclined plane, in normal force is always equal to the perpendicular component of the weight. So therefore, so calculator F some calculator mu k coefficient of kinetic friction times the normal force. The normal force is equal to this. So therefore, who's about mu k times normal force minus Fg parallel, it's Fg sine 30 degrees equal to what's the mass? It's 6. Acceleration, it's positive 4. Né? It's positive 4. Now I substitute as calculated tension. Mu for the 6 kg block it's 0.2. Ngoba sikhuluma nge 6 kg block in this question, so sizothi 0.2 times the normal force. The normal force here to it's Fg perpendicular, and the Fg perpendicular it's Fg, which is mass times gravitational acceleration times cos 30 degrees. So lana it's going to be 6 times 9.8, which will represent to Fg times cos 30 degrees. The equation there. Yeah, bora man. Now lana give a 6 9.8 sine 30 degrees is equal to 6 times 4. It's 24. It's 24. So therefore, social space less spacing it t minus as calculated this 0.2 times 6 times 9.8 times cos 30 degrees. 3 decimal places is 10.184 minus 6 times 9.8, same calculator this one, times sine 30 degrees is 29.400 is equal to 24. Tension it's minus 10.184 plus 29.400 is equal to 39.584 is equal to 24. Now T is equal to 24 transpose. It's 39.584 plus 24. Answer yethu tension yethu izoba 63,584 Newton up. Nayi answer yethu ke for 2.4.1. Right, now see 2.4.2. now lana bathi calculate the magnitude of F if the system moves up the inclined plane at a constant velocity. Wow, okay. 2.4.2. now sifuna calculate to F this time, and keep in mind F law is being applied for both objects, 3 na 6. So the F law move the whole system, not to 3 kg per, ne? Not to 3 kg per. Be careful on that one. So 2.4.2 is the magnitude of F. So in order to calculate the magnitude of F, let's consider the entire system. So calculate, so consider the whole system, the system as a whole. Ne? So if so consider the system as a whole, let's check wonke forces are acting on the horizontal plane. Wonke forces are acting on the horizontal plane. Remember, I'm considering the whole system. Ne? So 6 we experience a frictional force, as well as 3 we experience a frictional force, right? Now consider the whole system. The tensional forces are sort of like are cancelling each other out. So the tensional force lana for the 6 and the 3 as we consider for nanga besbega is system yonke, ne? So F for 6 kg block, and then in a frictional force as well for the 3 kg, in a 6 frictional force for the 6 kg and the frictional force for the 3 kg, right? And then given the weight component in the parallel plane, remember, consider the whole system. So for the for isoscenes bigger, only the forces are acting along the horizontal plane. So therefore, sizoba nani no FG parallel for the whole system. Ngoba this whole system nayo inani ne weight yayo. Angithi, like I'm trying to create a picture nyana for a free body diagram for the whole system, ne? And then izophinda ibe nani ne FG perpendicular, ne perpendicular component for the whole system, ne parallel component for the whole system as well. So therefore, we are only interested in the forces on the inclined plane. So it's now 1, 2, 3, 4 forces on the inclined plane. As was net or with this calculator F, ne? F net this time around is over equal to 0. Ngoba bakhuluma constant velocity, and the constant velocity we are dealing with first law, and our first law F net is always equal to 0. So F net is equal to the sum of all the forces acting on that plane. In this case, our plane is the horizontal plane. Therefore, as choose up the incline as positive. So up you have plus F. So you're gonna F plus F. Ngoba we are phezulu, and then wonke lama forces lawa 1, 2, 3 they are facing down. So you go minus FG parallel minus F 6 kilogram frictional force for a 6 kilogram, and then sibenani the frictional force for the 3 kg body is equal to 0. Tinasfuna the value of F, the applied force, minus FG parallel is what? It's mg times sine 30 degrees. Ne? sine 30 degrees. Okay, lena nai, this one nai, minus mu k times normal force for the 6 kg block minus mu k times the normal force for the 3 kg block is equal to 0. Now it's full F minus, what's the mass for the whole system? Remember, it's the parallel component for the whole system. So add lo 6 now lo 3 is 9. And then gravitational acceleration is 9,8 sine 30 degrees minus mu k for a 6 kg block. It's what? 0,2, and then lana sobano. The normal force for a 6 kg block, so as I've seen on the previous questions, is told ubani 6 times 9,8 cos 30 degrees minus 0,1 mu k now times the mass, it's 3, 9,8 times lana, I think lana, it's cos 30 degrees again, equal to 0. Now let's calculate again. So calculate this one, this one, this one. 9 times 9,8 times sine 30 degrees. Now answer ya corner asibhalelo F kuqala, which is the force esifunayo, minus 44,1 minus 0,2 times 6 times 9,8 times cos 30 degrees, 10,184 minus 0,1 times 3 times 9,8 is equal to 2,940 is equal to 0. F, now like terms, so it's 44,1 minus 10,184 minus 2,940. Answer it, it's minus 30. Minus 30. Minus 30. Minus 30. Is it? Minus 30. Right. Hey, wait. Okay. Yeah, there's something missing. It's minus 44,1 minus. Okay. So I think short a negative sign. So it's minus. Answer it about minus 57,224 equal to 0. Equal to 0, then F is equal to 57,224 newtons, 4 newtons up in incline. But let me double check the solution here. Or I think instead of doing it piece by piece. 9,8 sine 30 minus 0,2 times 6 times 9,8 times cos 30 degrees minus 0,1 times 3 times 9,8 times cos 30 degrees. Fascinating. Now your answer. It's 56,831 Newton. So what went wrong? I think okay, let's check it. This one is 9 times 9,8 times sine 30 degrees, it's 44,1, check. 0,2 times 6 times 9,8 times cos 30 degrees. Ngifuna ukubona ukuthi why ngithola ama-answers ahlukene. 0,1 times 3 times 9,8 times cos 30 degrees. Okay, ngilele, sengilele. Sorry guys. 184 minus 2,546. Voila. Haha. Okay. So this is not the answer, but this one is the answer. So 2.4.2 na answer ya corner. So our applied force, it's this one, up the incline. 2.5 ish. Yeah, ne? The calculation liabora le. No. Liabora. Okay, how the tension in the string calculated in question 2.4.1. This tension, as you calculated on the previous question, got 2.4.1, be affected if the system accelerates up a frictionless inclined plane at 4 meters per second. We want the accelerations are safana, but this time it's frictionless, aksana friction. Write down increases, decreases, or remains the same. Ne? Mina ngithi izo decrease. Ne? Izo decrease. The tension in the string increase because there's more resistance kule surface. Ne? There's more resistance kule surface, so there's more strain kule string ebamba lama blocks wethu. But once you are frictionless, we release the stress between the two blocks, meaning the tension kule string yenzani ya decrease nayo. So now question iphelela la. Question 2. Thanks for watching. Nangabe uyithandile le video, please leave a like. If ubona ngathi ngasiza omunye umngane wakho, please ishare naye. Nangabe une question, leave a question yakho in the comment section. In the description below, I've also linked questions, video to questions while a question paper ka grade 12, exemplar question paper ka grade 12 your physical sciences paper 1. Thanks for watching. Ngizokubona kule video ilandelayo. Bye bye.